In quantum mechanics, there are properties like position and momentum that famously cannot be measured at the same time. But what does it mean they cannot be measured at the same time? What if I just do? I can always perform a measurement when I want to, right? In classical physics, a particle has a sharply defined position and momentum at all times. In fact, this is what the entirety of classical physics is firmly based on. But in quantum mechanics, position and momentum are incompatible, or as we call it, non-commuting. Whenever you measure one, the other becomes unclear. What happens when I measure the momentum first and position next? I get a value for momentum. But as soon as I perform the position measurement, the momentum no longer has the value I just measured. My position measurement has destroyed the state the system has just been in before. And we can understand this a bit deeper with just a little bit of quantum mechanics. When I measure a particle's momentum, its wave function collapses into one momentum eigenstate, and I measure the associated eigenvalue. When I measure the particle's position next, this will immediately force the particle into a new state, an eigenstate of its position. And non-commuting variables have no common eigenstates. So any measurement I perform will force the system into a new state and out of the state it was just in. But there are also properties that do commute, for example momentum and energy, so they have the same eigenstates. Suppose I measure the momentum first, and when I measure the energy next, the particle would just remain in the exact same eigenstate. This is Heisenberg's uncertainty principle, and it isn't really about measuring. You always can perform a measurement and you will get a value, but what it does, it changes the state the system was just in. So what you measured is no longer applicable. So the more correct way to say it would be, a system cannot be in a state where both momentum and position are defined at the same time. So it's not about what we cannot measure, it's about what cannot exist. Subscribe for more quantum mechanics.